In this video, we're going to get into our first set of geometry definitions. So before we actually dive into any definitions, I just want to show you how to use this document. So on each one that I share with you, you should have this in our Google Classroom. On each copy of these, I'm going to share a table of contents, which is basically just going to lay out exactly which definitions we're going to go over. So we're going to talk about a point, a line, a plane. These are the definitions that I want us to define just today. You will submit this with me when I'm done, hopefully. You should still be able to access it after. I will return them just to check on them and then give them back to you, just so you still have access to it and you can review it whenever you need to. But when we're in each definition, this is the model that we're going to be used. It's called the Freire model. It just helps you, first off, easily define and describe whatever we're talking about, and then give examples and counterexamples to whatever the term is. So in the definition, geometry is super specific. The definitions need to be very concise, but also comprehensive. They need to include every possible example of that term, but you don't want to include anything that's outside of that. So you want it to be as narrow as possible, while also including everything that you need to include. The characteristics and drawing maybe should not be a repeat of the definition. They shouldn't be examples. It should be a description, something that makes sense to you, a description of what examples might look like. The examples, you should provide at least 2 examples of each. Sometimes it's easier than others, but the examples should be varying. So I'm going to get into my own example in a second, but they shouldn't be the same exact type. Non-examples is pretty clear in the name. Those are basically samples of something that's not that term that we're talking about. I think this is probably going to be easiest to understand with an example. So the definition, my example is going to be an irrational number. This is not one of our geometry definitions. It's just an example I wanted to use because it's kind of easy to show how these things would be used. An irrational number is a number that cannot be written as a fraction. So unfortunately, you may not have a tablet like I do, so I can easily write on these, but you can type those out. The definition, the examples, the non-examples, those are probably the easiest to just type out. The characteristics, and especially that drawing or picture of it, that might not be that easy to actually type in there or use the Google Slides to show it in there. So if you want to find a picture online and copy and paste it into there, that's perfectly okay. However you need to make this work for you, really this is your glossary, your set of definitions. The definitions need to be super specific and exactly word for word what I offer to you. The other ones are pretty much up to you. However you need to understand it is what works best for you. So I'm going to keep going with my example of irrational numbers. I'm going to do some examples first because that's probably easier. Pi is a good example. Square root of 2 is a good example. And this is what I mean by they should be varying. So I mean, there's not too many examples of irrational numbers, but E is another irrational and transcendental number. So these two are kind of similar, and those two are kind of similar. They're all irrational numbers. I just wouldn't stick to just writing something like that where it doesn't provide the breadth of the definition, really all the different types of examples that you might see. So when I think about a characteristic of those types of numbers, when I write them as decimals, they have 2 qualities. They go on forever, and they don't repeat. So I'm going to say number 1, number 2. Now those are not very mathy ways to say that. Go on forever is in no way a mathematical description of those numbers. Because technically every number goes on forever. If I said like 3.0, I could just extend that forever. But this is something that helps it make sense to me. It doesn't really matter if it's actually a mathematically, technically right way to describe it. That's what is in that definition section. So I want you to also include at least 2 non-examples. 3.0 is fine, or however many zeros you want to include. I'm going to do 7 over 2 just to show that it could be written as a fraction. And maybe I want to contrast it to that the square root of 7 is irrational, but the square root of 9 is rational. So this is how you're going to use these Freyer model type definitions. Oops, didn't mean to do that. So your first definition will be a point. And now I'm going to show you a couple resources. It doesn't need to be just from MathSpace, but MathSpace will be the easiest to use for this. This is the easiest resource because I'm lining it up with some of these lessons. So if you go to the MathSpace homepage, it'll take you to this, which then you try to log in. This does not accept your FCPS login information. You have to click Login with Clever. It's going to automatically sign me in. When you click on Login with Clever, you have to select Fairfax County and maybe even Liberty Middle School, and then use your Fairfax County login. Eventually, it will get to this point where it'll just sign you in automatically, or at least take you directly to the Fairfax login part. And all the links that I share with you will take you directly there. So you shouldn't have to worry about that step. I just want to make that clear in case you do go to the MathSpace homepage. I'm going to show you our first lesson and what I'm going to share with you so that you can complete those Freyer models. It's not going to look like this. Hopefully it's a little bit more user-friendly, but this is the first lesson I will be sharing with you. And you can see, you could read through this and it describes all of the ideas that we'll be talking about and pretty clearly defines the terms that we're talking about. So these definitions should be written down exactly as is. I don't think we need this italicized part. That's more of a description of notation. I'm going to check to see if that's true about all of these, if they're all italicized. Yeah, only include the non-italicized part. That is the definition that we want to include. The other part you definitely want to read, and maybe it could be a part of your description or your characteristics, but that's not really a part of the formal, concise, comprehensive definition that we want to include. So there's going to be times that I share other resources with you to use to actually define all of our terms. MathSpace will be a reliable one because I'm honestly thinking that it's going to have every definition that we need laid out in very simple, at least a simple format, but the geometry definition needs to be exact. So I definitely would not rely on Google, especially if you just Google what's the definition of a point. It's going to start going into very vague definitions, not a geometry definition that we want to use. So rely on MathSpace. If you need to expand your characteristics and drawing or picture of it, that's where you can rely on other resources that are up to you. But if you do have any questions about how to complete this, please let me know. Email me at any time, or hopefully we're doing this, at least this first one I know we're doing during class, so you can ask me right in front of everybody so everyone can get an answer to your question. Because again, I'm sure I've said this already, but if you have a question, other people are going to be wondering the same thing. So please be brave, ask your question so everybody can get some clarity.